Alright, in today's lesson we're going to be talking about geometric sequences. So now we've already dealt with arithmetic sequences, which is where we had a common difference and we added a specific amount to a value each time an occurrence happened. And we called that a sequence when there was multiple occurrences. Now we're going to be looking at geometric sequences. Now notice that's our question on the left, and on the right we have a formal definition. So we're going to fill that in. So when we talk about a geometric sequence, it is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio, which is identified by the variable r. Now the next question is, how do I find the common ratio? Well, to find the common ratio, divide any two terms that are next to each other right to left. Now notice I did say right to left. There's a reason for that. We do need to follow that process. So let's go ahead and give that a shot on this first example right here. So we want to find r. We want to know what is r equal to in this set of numbers. So I'm going to go from right to left. So I'm going to go to this right number and I'll divide it by the number to the left of it. For instance, I'll do 15 over 5. And that's going to give me 3. I could also take 45 and divide it by 15. And if I were to divide 45 by 15, that would also give me 3. Or I could divide 135 by 45. And if I divided 135 by 45, it would also give me 3. Now, so we have this reoccurring number, this 3 that keeps reoccurring no matter which set of numbers we take. And that means that is my common ratio. So I can say, well, my common ratio, r, is simply 3. So as before, we would have went from right to left and we would have subtracted the number from the left from the one to the right. When it's a geometric sequence, we are actually going to be using division. So let's take a look over here. Notice it says therefore r is equal to, and we'll fill in the number, it is equal to 3. Now notice that it does not matter which two terms you pick, it is always the same. So that's something that we're going to see in these geometric sequences, is no matter what two numbers we pick, we should always get the same value unless it is not a geometric sequence. So let's go ahead and put this to use. Let's find some terms using some of these ideas. Notice example 2 says, write the first 5 terms of the geometric sequence in which a sub 1 is equal to 4 and r is equal to 5. Okay, well let's go ahead. First of all, we've got to write 5 terms. So we're going to have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So we're going to have all of these values taking place. It's going to put us some arrows. So let's look at the first one. The first one, it tells us is a sub 1 is 4. Okay, so a sub 1 is equal to 4. Now we do know that our common ratio, right, is r is equal to 5, which simply means that over here to find the common ratio we use division. So if we know the ratio and we want to find the next number, we do the opposite of using division, which is multiplication. So simply we're going to take this 5 and we're just going to multiply it to our a sub 1. So there's my common ratio. I'm actually going to box this in black. So 4 times 5 is going to give me 20. So there's my answer. And then if I wanted to go ahead and continue this process, I could say, okay, well let's say that I want to go ahead and figure out the next one. Well, I would just multiply it by 5 again. So I'm going to box these as we go on. So we have 4, we have 20. And then I can say, well, 5 times 20 is going to give me 100. And if I wanted to know what the next one is, I would just multiply it by 5. And I would say, well, 5 times 100 is going to give me 500. And then I could go ahead and take this one if I wanted to go further, multiply by 5 again. I could say, okay, well, that's going to give me my a sub 5. 5 times 500 is going to give me 2500. So this is my ace of 5, that's my ace of 4, ace of 3, ace of 2, and ace of 1. So let me get my arrow. This arrow I should have left myself a little bit more space, so I'm going to curve it a little bit. Now this is a really simple way to find it, and if we only wanted to find the third term or the fourth term or the fifth term, well, this would be a good way to do it because it's very simple. However, if I told you I wanted to find the 1027th term, then this would be a very bad way to do it because we've had tons of math to do to try to get up to the thousands, and so it would take forever. Therefore, we are going to be introducing a formula that's going to make this a lot easier. But I do want you to know that this is what is occurring when we use the formula. So let's go to this next one. This next one says, example 3, write the first 5 terms of the geometric sequence, and it says which a sub 1 is 256, and the common ratio is 1/4. Okay, so before we multiplied by common ratio, that was an integer. Now we're using one that's a rational number, right? We're using a fractional value, in other words. So let's go ahead and use this fractional value and see what we come up with. So I'm going to go ahead and leave us some space here. So we have a sub 1. And we know that that is 256. So now what we want to do is we're going to multiply that a sub 1 by our common ratio of 1/4. And that will give us our a sub 2. Now, I'm going to be quite honest with you. When I'm doing these, I'm just going to go ahead and use my calculator right quick because I feel like this is just an easier way to do it. So let me go ahead and put this into my calculator. Alright, I'm going to go ahead at this point and I'm going to type it in. I'm going to say, well, 256 times, put my fraction bar, and I'll do 1/4. I'm going to put a decimal, so if I get a weird answer, it'll be in decimal form. And it says it's 64. So let's go ahead and write that down. Alright, 64. Okay, well, now we want to go ahead and let's go to a sub 3. So we're going to multiply it by the common ratio again so that we can get a sub 3. And I'm going to go back to my calculator and put that in. Alright, if I do 64 times 1/4, it gives me 16. So I'm going to write that number down. So it's now 16. Okay, so now I'm going to go ahead and find a sub 4. So I'm going to multiply it again by 1/4. Alright, I'm going to do 16 times 1/4, and it gives me 4. Alright, so we're going to write down 4, and now we're going to do our final one. We were looking to go all the way to a sub 5, so we're going to multiply 1/4 times 4, and this one I can do in my head. I say, well, 4 times 4 times 1 is 4, and 4/4 is just going to give me 1. And so that is my 5th term. Notice that this wasn't too bad to do. We had the calculator, so we could do the multiplication pretty easily. But again, if we said, well, we wanted to know the 564th term, this would be very time consuming. Not to mention, we would have an extremely small number, and it might be very difficult to do that by hand. So it'd just be much easier to go ahead and do that with a formula. So let's go ahead and take a look at what that formula is and how we can use it. Alright, in this formula, we are going to call this our explicit formula. So from this point on, whenever I say explicit formula, this is going to be the formula that I'm talking about. And notice that it has a sub n is equal to a sub 1 times the common ratio to the power of n minus 1. Now, I do, in case some of you forgot, I'm saying this kind of fast, and if some of you forgot how to pronounce these particular terms, I want to go ahead and go over them with you just real quick. Remember that when we talk about a sub n right here, we're actually talking about saying a sub n. And we call that, put your little arrow right here, the general term. That's what it represents. Put this little a up here, just notice, I'll have this corrected for you. On this next one, notice it says a sub 1. So a sub 1 is actually me saying really fast a sub 1. Now, when we talk about that particular term, we're actually saying this one, it actually means the first term in the sequence. Then we have R, which R is just going to be our common ratio. And last of all, we have N. And of course, we just say what the letter is, and it just means the nth term. Typically, that's just the term that we're looking for. So it's the nth term, or I like to call it sequence. Now, with that being said, you know how to say these different things right here. All these terms that you see, you know exactly what to call them and how I'm referring to them. So what I want to do now is let's go ahead and put this into use inside of a real-world problem. Now notice over here it says, how can I use the formula to find the nth term in a series? Okay, well this is how we do it. So we're going to use the formula for the general term, nth term, of a geometric sequence to find the sixth, I'm going to box that, term of the sequence with a sub 1 equal to 15,625 and R, the common ratio, equal to 1 over 5. Now, we have this information. I do recommend that you always box variables, equations, and numbers. So by having that box, that kind of gets that information together for us and gets it ready. So I think the best thing to do anytime you're doing one of these, and I want to see this written down on your notes when I grade them, I want to see that you wrote out the formula first. So we got a sub n is equal to a sub 1 times, I'm going to put a times right there, even though I don't show it, it means times, the common ratio to the power of n minus 1. Now, in this case, I'm going to be using pink to replace the n. So just keep in mind that anywhere there's an n, I'm going to go ahead and use pink. So I'm going to go ahead and rewrite this with my numbers in it now. So I got a, but instead of n, I know what term I want. I actually want to find the sixth term. So it's going to be a sub 6 is going to be equal to, and then I'm going to put the value for a sub 1, I'm going to put it in parentheses. So that value is 15,625. I do want you to notice that I did not put any commas inside of here, because if you put a comma inside of there, your calculator is going to give you an error. Do not put a comma, just put the numbers all together. Now, the next thing I need to do, right, because that was my a sub 1 right there, I need to go ahead and put my r. Okay, so what am I going to put for the r? Let me draw a little arrow. Well, my common ratio is 1/5, so I'm going to put 1/5. Now, that's then going to be to the power of 6, right, because we're replacing that n with a 6 because we know we want the sixth term, and minus 1. So then I'm going to put this in the calculator just like you see it, and it's going to give me my answer. And it really is that simple. Instead of us having to, do 6 different terms one at a time by multiplying 1/5, which we could have done that. 6 term isn't too far. It would have been possible. We can just use this formula and it'll give us the answer really quick. Alright, so I'm going to go ahead and put in everything that I have on the right side of my equation. So I had a sub 6 is equal to, parentheses, 15,625, and get out of the parentheses and put another set of parentheses, control divide from a fraction bar, and I'm going to put 1/5. I'm going to put a decimal in here just in case I don't get a clean number. I got to get outside of the parentheses now, hit the caret key, right, that little up arrow, so we can change our exponent, and I'm going to put to the power of 6 minus 1. Hit enter, and we have 5. So our answer is 5. So let's go ahead and record that on our paper now. Alright, so I'm going to put right here, a sub 6 is equal to 5. I'm going to box it. And that is our final answer. So I think looking at this seems pretty straightforward. So what we're going to do now, let's go ahead and go to this next one, and we're going to try this again. So let's do one more together. Then I'm going to cut you loose on some problems. It says use the formula for the general term of a geometric sequence to find the 10th term of the sequence when a sub 1 is 8 and the common ratio r is equal to 4. Okay, so we're going to go ahead and do that. First thing I'm going to do is I'm going to write my equation. A sub n is going to be equal to a sub 1 times r to the power of n minus 1. Alright, so now we're going to go ahead and do some replacement. So we're going to say, okay, it's going to be a sub 10, right? Because I'm looking for the 10th term. So a sub 10 is equal to a sub 1, which is 8. So I'm going to put that in parentheses. And then times my r, which is 4. And then that's going to be to the power of 10 minus 1. And then I'm going to go ahead and write a sub 10 is equal to, and we're going to have our answer. So let's use our calculator real quick. Alright, I'm going to go ahead and put in parentheses 8, and our common ratio is 4, and that was to the power of 10 minus 1 because we're looking for the 10th term. And it gives me a really large number. It looks like to me 2,097,152. So let's go ahead and document that number. Alright, 2,097,152. And that is our final answer.